Hey guys, welcome back. This is section 3 of the pendant of performance. This section is called short performance tips, which means that we're going to be giving you a few easy implementation switches that will affect your performance positively. Let's take a look. The first thing we want to give you is this idea that inheritance can help your memory efficiency. You want to be aware of taking single objects and loading them up with repetitive code that could be sourced and held somewhere else, ideally a prototype. Taking a look here, we've got the signal fire constructor. That's right, we're going to be building some signal fires. You can see that it takes an ID for the signal fire as well as a certain amount of starting logs that the fire gets. Additionally, you can see there are 3 other methods that are added in here: add logs, light fire, and smoke signal, which have all sorts of unique functionality for the signal fire. Now the thing about those 3 functions is that we don't need to build all of those methods within every single signal fire object, because it would use extra memory to store that functionality within every object, and it would also take longer to create when we're calling the constructor. So if we had this world-spanning signal fire system, right, with multiple fire objects, we'd have to replicate all of that functionality within each one of those signal fire data structures, which would suck. So let's take a look at a way we can improve that memory efficiency using inheritance. The way that we can avoid all of that repetitive memory usage is by using a prototype for all of our shared stuff. We want to give the common methods that each one of these objects will share. We want to give that to a prototype and then just have all the objects inherit from the prototype. Let's check that out. So we'll scoot down our smoke signal function here, and then we'll scoot over our add logs and light fire methods. Then we'll get rid of these equal signs and replace them with colons. And then we'll wrap the whole deal in the signal fire prototype. And now all of these methods can be inherited by every signal fire object. So now, if we have fire 1, fire 2, and fire 3 created through new constructions of signal fires, you can see they all start with an ID, as well as many starting logs as they have each. And then if we were to call add logs on each one of those signal fire objects, each of those signal fires would be accessing the method contained only in the prototype object for the signal fire. Additionally, if fire 3 saw some goblins and needed to alert their nearest neighbor, we could send a smoke signal on goblins and we would get G-O-B-L-I-N-S exclamation point, because goblins are serious. Moral of this short story: make sure that you add all common functionality to a prototype so that every single data structure that's inside of a class of objects doesn't contain that shared functionality itself. The next short performance tip that we want to give you is that adding individual DOM elements to the DOM is not always your safest, fastest friend. We want to make sure that you know that each new addition to the DOM is going to cause a document reflow. Ugh, that's terrible and can very often hinder user experience. Take a look at this website over here on the right. It's a Knights of the Week site, apparently, and we have an unordered list element there with an ID of KOTW list. Later on, there's a script tag that calls the KOTW.js file to be loaded. Let's take a look at that file. Inside there, we grab that unordered list element and assign it to a variable list. And then we've got this list of the Knights of the Week. There they are: Jenna Range Spike, Nearic Farthing, and Darkened Stonefield. Next, we've got a for loop that loops over all of the Knights of the Week, and first, for each element, creates a list item element, and then adds a text node with that particular knight's name to that element, and then adds the element itself to the unordered list element inside the HTML page. Now, each time that list is appended, you're going to access the DOM and you're going to cause an entire document reflow. That's not as speedy as we'd like it to be, especially if our list was 4,000 knights assigned to this regiment for printout. That would suck. So we don't really want that to happen. Let's take a look at a way to speed that up. Cool thing about HTML is the document fragment, which can be used to insert a whole bunch of conjoined additions all at once instead of in pieces. Fragments are like invisible containers that hold multiple DOM elements without actually being a node itself. They're very cool. Let's take a look how to use it. So what we're going to do is we're going to create an extra variable here called fragment, and then we're going to use the .createDocumentFragment method to assign a new fragment to that variable. What that fragment is going to be is sort of a staging area. It's going to hold all of our new LI elements for our page. Now on the inside of our loop, instead of adding our created element with the knight's name as a text node to the actual unordered list element, we're not going to do that anymore. We're going to now put that element inside the fragment as a staging area. Now we'll need to add another line right after our loop that will finally add the fragment that contains all of our elements to the document. Notice that this is happening in one fell swoop. We're only touching the DOM one time in order to add all of those elements to the unordered list. Now we're going to give you a little bit of a side bonus best practice here. We want to make sure that you declare variables as few times as possible. That's because every time you use one of those var keywords, it's going to add an extra lookup for the JavaScript parser, and that can be avoided with those comma extensions that we saw in the first section of this level. Let's take a look. All right, so we've got already vars on list, KOTW, and fragment. And if we take the vars off of KOTW and fragment, we can put commas, comma behind the list variable as well as behind the KOTW variable. That will show that we're declaring multiple variables in a row, just as we did in that looped optimization segment. Now using these commas is really great for legibility for when other developers are looking through your code. They can see that you've got a nice list of variables stacked using commas. Now because of that processor burden, you want to avoid declaring in loops. You want to try to anticipate your variable needs so that you're not causing the parser to look that variable keyword up over and over again, right? Let's take a look at that. Here you can see our var element, and that variable is going to be declared every single time our loop executes. That means we're going to need to look up what the var keyword means every time we want to declare that element. Now some will argue that declaring variables right when they're needed is very useful because it tightens the understanding of your code so that people can see that you've declared this variable right where you have needed it. But you want to kind of weigh that with the trade-off of the processor burden. Now since our script here is sort of very small, we're going to go ahead and declare that element outside of our loop and then use the element inside the loop. So first thing we'll do is we'll get rid of the var on that element inside the loop, and then we will add the element to the list of the variables outside the loop. That's a great trade-off because we've got such a short script. We've opted to avoid processor burden instead of having the element declared exactly where it is used. Now the goal here is to make sure that you anticipate which variables you'll need ahead of time so that when you encounter loop environments in your code, you won't need to redeclare those variables over and over again. The last little performance tip we want to give you in this section is that we should always make efficient choices when we're trying to figure out how to concatenate a set of strings that we have. In building strings, there are several different methods that will yield uniquely different results in terms of execution speed. So let's take a look at that. Here we've got three new variables, knight, action, and weapon, each with a string inside it. Next we'll have a variable called turn, and what we're going to do is concatenate all three of those variables together to create GenerateSpike's turn. Now here the standard concatenation operator has been optimized in most browser versions. That's an ideal choice if you are using a small number of string concatenations. But one more time, the concatenation operator will probably be your best bet if you have just a small amount of strings to concatenate. However, if we had a variable that consisted of an array of multiple hundreds of HTML elements, for example, if we were pooling HTML elements together to build a new page, we may want to loop over that array in order to put all of those elements together. So here you can see we've got a page variable, right, starting out at the empty string. And then we loop over all of those array elements forever, concatenating. And that's going to get the job done, but there is another method that will enjoy a performance boost, specifically when your strings are inside of an array. Always want to decide what's better before reaching specifically for that concatenation operator. When you are trying to concatenate the strings that are inside an array's contents, instead use the native join method on arrays. That's going to be inherited from the array prototype. Here you can see us use the join method on the new page build variable, and what that's going to do is concatenate each index of our new page build array, and those indices are going to be joined by any string that you pass into the join method. Here you can see we've got the new line going in there so as to put a new line between each element of our new page build long string. When your strings are in an array, this method is going to be extremely faster than using that concatenation operator over and over again in most of the tests that we've designed for it. Also, it's a little bit easier to read because a developer can understand exactly what you're doing rather than trying to figure out what your loop is trying to accomplish. Now that we have joined all the elements of our array using new lines and put that into our page variable, if we were to log that page out now, you can see that our HTML page is grouped very nicely with new lines in between as one long string. Super cool. And that's the end of this short performance tips section. We're going to give you a few challenges so you can illustrate your learning with these magical things, and then we will see you back in the next section.